Welcome everyone to the Trimble Geospatial webinar, combining point clouds with imagery in eCognition. My name is Christian Weise, and I am the eCognition product manager. I think everybody has heard about the combination of raster and point cloud data in eCognition, but anyone knows a lot about this. That's the reason why I would like to tell you something about the new point cloud features in eCognition today. This webinar is structured into 3 sections. At the beginning, a presentation, in the middle, a hands-on session with live demonstrations, and the end will be a question and answer part. As you probably know, our current version is eCognition 8.7, and the 3 main highlights are the new object-based point cloud analysis capabilities, the new sample-based classification algorithms, and the new array data structure. We released this version in September last year, and our customers with a valid maintenance contract can download and install and use the software. The first highlight in eCognition 8.7, the new object-based point cloud analysis capabilities, is the topic of this webinar, but I will give you also a small overview about the machine learning and the improved development environment. Now something about the machine learning. We added a new process to eCognition which offers some state-of-the-art machine learning algorithms like CART and support vector machine. With such supervised classification approaches, it is now possible to tackle complex mapping problems, for instance, to classify hyperspectral data. But it is also the idea to combine the sample-based classification approach with typical object-based image analysis steps in eCognition. For instance, you can start your analysis of using the machine learning algorithms to classify the basic land cover and then optimize the results with growing, shrinking techniques to use the neighborhood of the object to improve your classification. The third highlight, the new array data structure of the improved development environment, describes a collection of rule set elements like image layers, variables, features, or things like that. Rule set developer can use such collections now instead of defined single elements to create flexible rule sets, which are able to react on different situations like unknown class names or unknown layer names, etc. But arrays itself do not solve an image analysis problem, but it helps us to create flexible rule sets. Now I want to give you an insight into the new capabilities to use point cloud information in eCognition. First, in eCognition 8.7, we can classify and export point clouds now. The new export algorithm named the LiDAR file export supports the LIS file format and the classification of the points. Based on classify image objects in an image object domain, we can assign the LIS classification tag to the corresponding points of the object. It is possible to classify all points under the objects to a class or to filter the points based on the LIS classification tag and the returns. It is also possible to filter the points for the classification based on an image layer comparison to restrict the classification. I want to give you an example during the hands-on session. The second new capability to use point cloud information in eCognition are the new point cloud object features, which you can find in the feature view. Such point cloud features, or better would be object point attributes, gives us more information about the 3D structure of objects than 2D raster elevation layer. The new features describes the 3D structure of 2D segments. We call this selector 3D. But all information will be directly calculated from the XYZ information of the point cloud. Bottom line, in eCognition 8.7, with the new export last file algorithm and the new point cloud features is it now possible or offers now a streamlined analysis of point cloud information. It is possible to load point cloud data in eCognition. It is possible to combine point cloud data with image data and vector information in eCognition, to use information from all these three kinds of input information to classify segments in eCognition. It is also possible to classify the points of the given point clouds, the last file, in eCognition 8.7, and to export the point cloud files into the LRS file format. Now some words about the new point cloud features. The new features gives us statistics on the height of the points, if we use the elevation, of the return intensity of the points, if we use the intensity group of this new point cloud features, and the coverage of the points, the number of the points. All these features are also known as LiDAR matrix. Each real-world object will represent in eCognition as a 2D object, as you already know, as a segment. And the new point cloud features helps us now to use the full information potential of the LiDAR dataset. For the new features, we have to select only 3 parameters to use them. The first is if it available, the input point class, the input return information, and the calculation mode. If the point cloud file is already classified, we can use the class information to filter the points which will be used as input for the features. Another restriction could be also the returns. Here you can see all returns of object, of this theoretical object, and with the return parameter we can restrict which points will be used for the calculation of the object feature. The parameter all return means we use all the points which are covered from the segment. First return means eCognition will use only the first target encountered by the laser pulses. And last return means eCognition will use only the last return for calculating the point cloud features. The last parameter of the point cloud features are the mode. Here we define which algorithm will be used for calculating the feature. There are some typical algorithms available, maybe the average or the minimum or the maximum, but it's also possible to calculate the feature based on the mode. That means the most frequent value or the median, the middle value, I think so. And if you create a feature based on the minimum of all returns, in this example we will use only this point to calculate the object feature. If you use the first returns to restrict the given points, the eCognition feature will calculate it based only on this point, if you use the minimum. It's also possible with the maximum and of course the average. And here you can see the difference between the different returns parameter. If we want to have the ground elevation of the objects, I would like to use the elevation, the median elevation of the last returns to get the object values for the ground. Okay, bottom line. The point cloud features are configurable based on the LRS classification tag, the return, and the operation mode. And the new point cloud feature provides, I think, a more intuitive interpretation of objects than using raster representation of the elevation or intensity. They give 2D objects 3D information, if we use the elevation, and help us to use the full information potential of LiDAR files in eCognition. The power of object-based image analysis in eCognition is to combine now such point cloud information with color information based from images, if they are available, to classify segments. Multi-sensor datasets, that means datasets based on LiDAR and optical imagery, provide such detailed information, and you can fuse and analyze such datasets easily now in eCognition. At the moment, there are different multi-sensor airborne systems in the market, and the hands-on session, the followed hands-on session, is based on the Trimble Harrier dataset. The Trimble Harrier system is an imaging and laser scanning system, and it combines a full waveform laser scanner with an aerial camera, exactly the TAC, the Trimble Area camera. That means you will get point cloud information and RGB images in one overflight for your project area. Such systems are ideal for corridor mapping and aerial survey. Now I want to move to the hands-on session, and I want to share the eCognition application now for you. Here you can see a subset of a Trimble Harrier dataset. This small project contains an RGB image with a spatial resolution of 10 centimeter and a LiDAR point cloud file. Here you can see the RGB information and raster presentation of the LiDAR file. Based on this data, I would like to give you now an example on how to combine such data or such information to classify elevated vegetation in eCognition. To do this, I load a rule set. And the first step is now to create objects based on the RGB information. To do this, we're using the multi-resolution segmentation only based on the blue, green, red layer of the data set. I want to execute this now. The reason why of using the RGB layers for segmentation is that such data are continuous and they have a higher spatial resolution than the LRS dataset. After the processing time, you will see that the segments follow the image object perfectly. The next step is now to pre-calculate the point cloud features. We added a new algorithm into eCognition 8.7. It's called pre-calculating LiDAR fine matrix. And the idea behind this algorithm is to increase the performance of the point cloud features. That means with it you can calculate and cache the values of the new point cloud features in the run-up of using them. We will improve this in further versions, but at the moment I suggest that you execute the pre-calculation before you want to use the point cloud features. If you are using the point cloud features without the pre-calculation, eCognition will contact or load the LRS file for each object. For many objects this is a very time-consuming process, but for some objects the performance could be okay. And it's very simple to use the pre-calculation because you have to select only the image object domain, the objects, and the LiDAR file and the return parameter to do this. But now I want to show you the new point cloud features. The new point cloud features are stored under object features because they are object-based. And at the moment we have three groups, the intensity information, the elevation information, and the number of objects, the number of points. And if we want to see now maybe the average intensity of our returns, you can create such a feature and display the information very easily in eCognition. Or if we want to see only the minimum elevation of the last returns, you can insert such a feature and show the values for the whole project. Again, all features will be calculated now directly from the XYZ information of the LiDAR file. And the next step is now to use the new point cloud features to classify elevated vegetation objects in the dataset. To do this, we are using the fact that elevated vegetation object has multiple returns per pulses. That means such objects, such image objects here, have first and last returns. We can use this fact really easily by insert and customized feature, which formula calculates or divided the number of the last returns from the number of the all returns. The trick is that after this, or based on this formula, all objects with values greater than 1 have multiple returns per pulses, and we can use this feature here to classify elevated vegetation very easily in one step. Here you can see the feature, and I want to split the screen now. You can see the image, and such a feature here, that's a tree, has values greater than 1, and maybe a feature like the street has values close to 1. And based on a very simple classification process, that means to assign all unclassified objects, which object features based on the point cloud features are greater than 1.1 will be classified as elevated objects, elevated vegetation, and after processing you can see here the result. And the power of such multi-sensor dataset is to combine the different available information in the classification process. That means in the next step we can use the color information to optimize here this classification, and a really robust approach would be to reclassify all elevated vegetation objects which at the moment classified, which are not green. That means we use a very simple green ratio. If the green ratio are lower than 0.35, this object will be classified to unclassified. That means we reclassified all the dark areas and non-green areas. And now that's the power of object-based image analysis. We grow the elevated vegetation seeds into the neighborhood if the neighborhood object has multiple returns and a common border greater than 50%, and we will run this in a loop to optimize the classification based on the color information. The next usage of our new point cloud feature is to separate the elevated vegetation now into different height classes. To do this, we can create a very simple customized feature which gives us the relative height for each object in the project. And it's very simple. We subtract the minimum elevation of the last returns from the maximum elevation of the first returns. That means each object value will get the relative height, because the minimum elevation of the last returns is based on the lowest elevation, and or gives us the lowest elevation for each object, and the elevation maximum of the first return the highest value. And based on this feature we can classify now step by step the vegetation into different height classes. Maybe here we can say all temp objects which relative height is lower than 2.5 meters has to be classified into the class lower than 2.5 meters. And the next step is the same procedure, but we use another value, another threshold. All temp objects with relative heights are lower than 5 meters will be classified to this class, to the 2.5 to 5 meters. and followed by the other classes to classify the whole image. In summary, we use the RGB information to create objects for the whole project. In the next step, we use the point cloud features to find the elevated vegetation based on the multiple returns of the objects, followed by optimizing the results based on color information from the images. And the last step was to separate the different heights of the elevated vegetation based on the point cloud features. Such an approach is really robust and transferable to other projects. I want to show you. Based on the rule sets, we are able now to submit the whole project to the eCognition server. It's very simple. I want to do this, and during the processing time, I can show you also some other results, maybe this project. And here you can see the results of this project. This project contains also the RGB information and the LiDAR information from the Trimble Harrier dataset. The RGB information has a spatial resolution of 10 centimeters, and based on this object, based on this project, you can see it is really simple to classify the elevated vegetation based on the new point cloud features in eCognition. It is also possible in eCognition to convert the point cloud information into raster layer. To do this, you can use the LiDAR converter. Very simple. And if we want to see now maybe the maximum elevation of the given point cloud, we can create a raster presentation of the information. And after the processing time, this project will contain a new image layer, a temporary image layer. I want to display this now. And here you can see now the different points, and I want to change the equalizing mode now. Based on such a trick, you can see how dense is the point clouds and the image data at the moment in this project, and which points will be used for each object to get the point cloud features, maybe here in this case. Finally, the last new algorithm to use point cloud data in eCognition is the LiDAR file export. With the LiDAR file export, we can create a new LS file with eCognition, and it is also possible to classify the points of the last file. To do this, it's very simple. Maybe we want to classify all vegetation objects which are lower than 5 meters in the LiDAR file. And if the LiDAR file is already classified, maybe in ground and non-ground, we can use this information now to restrict the points. Maybe we want to override the classification tag for all non-ground objects. We have to set up this one and to classify this now to low vegetation. That means with this section, all points which are under objects which are defined here in the image object domain, and the classification tag of these points are non-ground, will be now override with the new LiDAR classification class low vegetation. That means we have to execute insert a rule for each classification tag in eCognition. Maybe we want to also override the classification tag for objects which are greater than 5 meters to maybe high vegetation. We have to set up this very easily. Okay, that's all about the hand-on session. Now I want to go back to the presentation. Please note, all the information from this webinar is also available in the eCognition community. That means the show Trimble Harrier dataset, the presented rule set, and the presentation itself. The eCognition community is a part of our website and provides an integration environment for collaboration and knowledge transfer. You can follow discussions there and ask questions if you want. In the file exchange, you can download and upload rule sets and also data sets. Here you will find also the data from the webinar here. And there are also some special spaces available to give the product management feedback about your wishes and to the next versions and or feedback about the current version. This is something what this space is called eCognition Ideas. And you will find there also another space called eCognition Labs to use, to download and to use prototype algorithms of eCognition 8.7. Currently, there are over 5,000 users at the moment registered, and it would be really nice to see you there and to get some feedback and questions about your problems or your wishes in eCognition. Thank you very much for your interest, your attention, and all your questions. And bye-bye.